Let's go about this from a different perspective. Let's determine what family of functions each of these are based on a table of values, not an equation. Now we could try to find the equation. You could do some regression on these, and there's fantastic things you can use for that. Desmos, calculators, those kinds of things. But we're just going to look at the numbers, and then we'll plot them as well and just kind of get a visual for it. And we're going to start with one that's relatively easy. One way that I like to determine the type of family of functions that we're dealing with, the family that we're dealing with, is looking at the rate of change and seeing if that rate of change is constant or not. So let's look here. As we go down the x column, that's not what I intended to do, but as we go down the x, there we go. As we go down the x column, we're going from 0 to 1 to 2 to 3 to 4. So as we do that, we're going increasing by 1, right? As we do this, we have 3 to 1, 1 to negative 1 to negative 3, negative 5. These are decreasing by 2 consistently. So because these are all adding 1 as we go from one to the next, we basically have the possibility of a linear function. And this actually is, and here's why. Because as we move from here to here, as I said, we're going down 2. So from here to here is negative 2, from here to here is negative 2. And because of, and here's the big idea, I'm not going to write it down, but because of the consistency of the rate of change, this one is going to be linear. Now, we could also plot it and see that it's linear. So let me grab the purple pen. We're going to write down that this one is linear. And again, the reason why is because this was a consistent rate of change as we moved from one y value to the other. That only works if we have consistency over here on the x as well. There are other little tricks that we can deal with. Let's take a look at this graph actually, the scatter plot that would correspond to this graph. And where is it? It's going to be here, and we're going to go to browser, and it is the first problem on the back. There it is. And it's these purple dots right here, and that is indeed linear. So we do have a straight line, and so that's what we're dealing with. Now we are assuming that that's all that we really need to see. It's not making some turn and going some other direction like an absolute value. So kind of an assumption, but that's okay. All right, let's go back to, where is it? Give me a second to find. There it is. There's got to be a faster way to get there. And y'all are already Googling like faster ways to get to the visualizer. Okay, let's look at the next one, and we're going to use the same idea. Like, do we have a consistent rate of change? For the x's we do, we're increasing by 1 every time. And if you want to write that, you could. You could say, oh, from here to here is up 1, from here to here is up 1, from here to here is up 1, from here to here is up 1. You don't have to write that, but it's just good to see. Now, as we go from here to here, we're decreasing 3, right? So from 3 to 0, we lost 3. From here to here, we lost 1. From here to here, we gained 1. And from here to here, we gained 3. Okay, here's a cool trick I learned in a workshop, actually, a teaching workshop. And I'll go ahead and tell you, this one's not linear, and it's fairly obvious that it's not because we don't have a constant rate of change. But if we do the second rate of change, we're getting into some calculus here, actually. If we do the second rate of change and we say, okay, well, what's the difference between negative 3 to negative 1? Well, it looks like we added 2. And we do that, we added 2. We do that, and we added 2. Because the second rate of change is constant, this one is quadratic. Okay, so you want to watch the fingers here. If I have the first rate of change as a constant, it's linear. Linear is to the first power. If the second rate of change is constant, it's squared, so this one's quadratic. So this guy right here is quadratic. And you could look at the graph and see it, and we are going to do that right now. And it is here. And it is number 2. There it is. You can look at that and tell that it is basically a parent function x squared that was shifted down 1. We can look at the numbers and kind of see that as well. So at 0 instead of 0, we have negative 1. And at 1, instead of what would be a 1, it's at 0. So it shifts down 1.